I'll try to keep this third video short. What's nice about f of x here is they already have it in factored form for you, -2, 1, and 3. And the only thing that you don't know yet is what kind of polynomial it is. So you could multiply all of these out. The only thing is you'd probably get tired and bored after a while. So if you just look at the leading, like the x term, I guess, and just multiply the x times the x times the x, it's going to give you a positive x cubed term. Now, obviously, there's a lot more going on. If it's also helpful, let me do this in a different color, you can multiply all of the constants together. So 2 times -1 is -2, times -3 is a positive 6. So the reason why I would do that is that's your indicator that your y-intercept would have been 0, 6. Which should make sense, because if you plug in zeros for all of your x's, that you're actually finding a point on that curve. But the entire reason why I bring that to your attention is your end behavior now is down and to the left and up and to the right, which is actually confirmed because since polynomials are continuous, which I don't know if 0, 6 is a maximum, it might be, it's probably not though, that you have to connect all these dots. So finding that y-intercept could help you understand, the only way to go from -2 to 1 has to go up first to hit that point. You couldn't go down and still be continuous. If that didn't make sense, then I apologize. I wasted a little bit of time. As I look at the next one, again, just think about that x equals -1 has a multiplicity of 2. And then x equals 2. And so 1 bounces and 1 crosses. Again, it might be helpful, to consider that you have x squared times x, which would give you a positive x cubed. But it also might be helpful to plug in zeros for x's. And so you'd be left with 1 times -2. So then your y-intercept would go to 0, -2. Right there. So since the only way to connect these points is to go back down, and it has to be on this end of the graph, it's confirmed that our end behavior is an odd degree and a negative leading coefficient. That was a terrible arrow. I'm trying to think of other clues as I do this, because this is going to be a short video otherwise, but I don't want to over-explain something. And I really do need to get down to this k of x down here, so and g of x for that matter. So looking at the next one, we have x equals -2, has a multiplicity of 2. I'll just write plus or minus 2 because they both have a multiplicity of 2. So if you have a short way of doing that, that's fine. And then notice we have a negative leading coefficient, because if you did x squared times x squared, that's x to the 4th. So it's negative x to the 4th, ... And if you wanted to, you could actually figure out what that last constant is by plugging in zeros for all those x's. So 2 squared times -2 squared would be 4 times 4 is 16 times negative. So it's -16. So it's going to hit way low on here, which would then confirm when you look at -2 and 2, and they just bounce off of those axes, off of the x-axis, I guess I should say. It confirms that you have a negative leading coefficient, so the end behaviors are both falling, just like that. I think I'm answering everything in the directions. Hopefully I'm not missing anything. So the next one, x equals -3 has a multiplicity of 1, but x equals 1 has a multiplicity of 3. So -3 and 1. Now, if you were to multiply this out, it would be x times x times x times x. So it's going to be a positive x to the fourth, dot, 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 dot. There's a lot in between. And if you plugged in zeros for all your x's, you'd have 3 times -1 when you cube it. Well, -1 when you cube it's still negative. So times 3 would make it -3. So I know it's going to be below the x-axis, right here. And remember, x equals 1 has a multiplicity of 3, so it's got to change concavity. It's got to be more like an upwards U and a downwards U on either side of that. And then at x equals -3, it has to cross without changing concavity. And you can confirm that you have a positive leading coefficient, even degree, and they both rise on either side. If you think of another trick to this, feel free to share it with me. Maybe it works all the time, maybe it doesn't. Okay, so this one, I don't know why the author wrote it like this. Maybe to remind you that this is another way that you can show that you have a multiplicity of 2. X equals -1 twice. And then this one is just x equals 3. Now be careful here, because they switched these two around. So if I were to ask you what the degree is, it's really x times -x. So it's a negative x cubed. So that means it's going up and to the left and down and to the right. Now at x equal, well, I guess because I've been saying it a lot, you can find the y-intercept by plugging in zeros for all these x's. You have 1 times 1 times 3, so the y-intercept will be at 0, 3. Which would then confirm that at x equals -1 has that even multiplicity, just has to bounce off that axis, go up, and then it will actually cross at x equals 3. And I don't like where I had that other one, so I'm going to erase it, not highlight it, erase it. There you go. And then doing the next one really the same way. We have x equals -3. If we set this piece equal to 0, it would be positive, because you subtract 3 over and divide by -2, so positive 3 halves. And then this x equals 3 has a multiplicity of 2. I'm just write M2 to keep this going a little bit faster. -3. 3 halves is about 1.5. So what kind of degree do we have? Well, if you did x times -2x times x squared, that would give me -2x to the fourth. And then there's a lot in between. You could actually figure it out if you want to. It's just a lot of work. Now, be careful here, because if you plug in zeros for all these x's, this is actually -3 squared is positive 9 times this 3 times 3 is 9. So that would be positive 81. So it shoots all the way up here. Like I can't even draw. I'm not even going to try to draw. So we have a negative leading coefficient. Even degree needs to fall on either side. Something like this. So it crosses at x equals -3. Multiplicity is 1. Has to go all the way up to 81. And again, I don't know where the max is. So I'm just giving you lots of options. It crosses again at 3 halves. And as it goes up back to 3, it just bounces off of 3, and it confirms our end behavior. I hope all of this made sense. That's all I want to talk about, and I think you are ready for the homework. Feel free to rewatch any of these videos.